Hello, Stings. We are ready to do our notes for combining like terms and the distributive property. This will be on page 3 of our notes in our iPod. Our date is August 30th. So first off, we need to define combining like terms. So what are like terms? Like terms are terms that have the same variable or variables and they are raised to the same power. So we have the example 5xy to the second and 7xy to the second. They both have an x, y to the second, and it doesn't matter what the number is in front, it's the variables that determine whether they're the same. So the x's have the same power, the y's have the same power, and we have just x's and just y's, so those are like terms. In order to combine like terms, we're going to draw lines in front of each plus or minus that we see to separate the terms. We're going to color all like terms the same color. You will need at least 3 different colors. I will be using orange, green, and blue. And then after we have things colored the same color, we're going to simplify each group into one single item. So, step 1, draw lines in front of each plus or minus to separate the terms. Let me make this a little larger for you. I'll move this over. Alright, so it'll get focused in a moment. Alright, so here we have 5x plus 4 minus 2x plus 3 minus 2x. So we're going to separate those terms between the operation and the number. The sign always goes with the number behind it. So the minus goes with the 2x. The plus goes with the 3. The minus goes with the 2x. For this example, the second example, we have 3x squared minus x plus 7 plus 5x plus 2 minus 2x squared. Again, draw your line between that operation and that term before. So this is a negative x, a positive 7, a positive 5x, a positive 2, and a negative 2x squared. The sign always goes with the number behind it. The signs in front here, both of those are positive. Because they're positive, we do not have to write those down. Write the positive sign down, that is. Okay, so what we're going to use now is orange for me. I'll use orange and green for this first example. I'm going to put my x terms, and I'm going to color all of those terms orange. So there's a 5x, here's a negative 2x, and a negative 2x. For the constant terms are what we call those numbers that don't have any variable associated with them. So we have a positive 4 and a positive 3. So what I do now is simplify each group. I'm going to write each group and simplify it and then put that together. So we have 5x minus 2x minus 2x, and that is going to yield us a positive x. Because 5 minus 2 is 3, 3 minus 2 is 1, so we get 1x left over from those guys. The next group were our constant terms, so we have plus 4 plus 3, which is then going to yield us a positive 7. So what we can do now is compare these two guys. X and positive 7 are not like terms, because they do not have the same variable raised to the same power. So my simplification here is going to be an x plus 7. There's nothing I can do to put those together anymore, but I have simplified my x terms down to one item and my constant terms down to one item, and then I just put both of those items in my answer. For the second example, I'm going to use blue for the x squared terms. I have 2 x squared terms. The first one is 3x squared. The second one is negative 2x squared. Again, I will use orange for the x terms. I have a negative x and I have a positive 5x. And finally, I will use the green again for the constant terms. I have a positive 7 and a positive 2. So with the blue, I will write down my x squared terms. I have a 3x squared and a minus 2x squared. Those guys, when you combine those, will give you a positive x squared. The x term is this negative x plus 5x. When we take a negative 1 and a positive 5, we get a positive 4x. Then our constant terms of a positive 7 and a positive 2, 7 plus 2 will give us 9. Now we have our three terms. They are not like terms, but we need to put those together in our final answer. So we're going to put the x squared term first. Variables get written first, and they get written in descending order of exponents. So we get x squared plus 4x plus 9. Constant terms are always last. So there we have our combining like terms. And the next thing we're going to look at is the distributive property. The distributive property says if A is multiplied by the sum B plus C, then what you get is A times B plus A times C. And what's happening there is this A is getting multiplied by this B. This A is also getting multiplied by the C. So that's a very simple example for number 1. This 4 gets multiplied by the x, and it also gets multiplied by the 3. 4 times x is 4x. 4 times positive 3 is positive 12. And you have 4x plus 12 as that distribution. The second example, we have to be very careful here because what we have is a subtraction problem right here. But remember up here when we were drawing the lines to separate our terms, we would have drawn a line between this 5 and this subtract right here, which means that we have 5 and then we have this negative 7 that's being distributed to both of these guys. So let me take this orange, and I'm going to show that this negative 7 is what's being distributed. I'm going to use a pen for this one. So I'm going to take the negative 7 and multiply it by the 3x. And I'm going to take the negative 7 and multiply it here by what amounts to a negative 2. Now this 5, he's just along for the ride. So I'm going to write the 5 down. Then I'm going to multiply negative 7 times positive 3x, and I get negative 21x. Then I multiply the negative 7 times a negative 2, and I get a positive 14. Now we have the situation like we had above. We need to combine like terms. So we draw our line here, we draw our line here. We have a constant term, an x term, and another constant term. There are no other x terms but the negative 21x, and x's come before constant numbers, so I'm going to go ahead and write down the negative 21x. Then I'm going to take the 5 and the 14. So, whoops, wrong color. We'll just go ahead and take the 5 and the 14, if I can pick up the right pen here. Here we go. This 5 and this positive 14, that's going to be 5 plus 14, and that will yield 19. And that is where we have applied both the distributive property and combining like terms. You just need to be careful here that you don't try to distribute the 5. It's 5 subtract 7 times this, 7 times this. So that subtract really becomes a negative, and we distribute it along with the 7 because whatever sign is in front of the 7 is stuck to the 7. Just like back up here, that negative stuck to that x, that positive is stuck to that 5x. So the sign in front sticks with the number, and you just distribute it, showing your work by drawing your arrows over. So this is page 3 of your notes. And this is combining like terms and the distributive property.